Question number 21. Consider the following statements made about the information that can be obtained from the dimensional analysis. Part A. Numerical values of constant of proportionality that may appear in a physical equation can be determined by dimensional analysis. We know that constant values has no dimension. Therefore, we can't analyze constant values in an equation. Therefore, statement A is incorrect. Part B. Numerical signs of constant proportionality that may appear in a physical equation can be determined by dimensional analysis. Now we can't analyze numerical signs. Therefore, B also incorrect. Then statement C, the units of constant of proportionality that may be appear in physical quantity can be determined by dimensional analysis. Yes, we can analyze if there is a unit in a proportional constant in an equation, then C is correct. Statement C is correct. Only C correct. Only C is true. Answer is 3 for the question number 21. Then 22. SI unit of Planck's constant is. We can get Planck's constant by using equation. We know that energy of a photon E equals hf. Then we can subject h. H is the Planck's constant. E divided by s. E is energy of photon. F is frequency. Then we can substitute values, substitute units. E is energy. We can measure it by joules, and F is frequency. We know that unit of frequency is hertz. It means per second. Then we can get s to the power minus 1 to the numerator as s joules second. Then answer is 2 for the question number 22. Then question number 23. As far the units are concerned, which of the following quantities differs from the first one? Rotational kinetic energy. We know that it is a type of energy. Therefore, we have to use unit joules. Then mechanical potential energy. It is also a type of unit, a type of energy. Therefore, we have to use joules as the unit. Then third one, internal energy. Also an energy. Therefore, we can use joules. Work. It is we can measure work by joules. Finally, fifth answer, power. We can't measure power by using joules because of it is energy per second. Energy divided by time. We can measure power joules per second, or we can use watt to measure power. Then fifth answer is question number 23. Fifth answer is the answer for the question number 23. Then 24. Which of the following quantities are dimensionless? A. Relative velocity. We know that relative velocity has units, and relative velocity means sum of two velocities or difference of two velocities. Therefore, it has dimensions. Therefore, it is incorrect. We have to select dimensionless quantities. Then B. Relative density. We know that relative density is density of material divided by density of water. Then there is a ratio between two densities. There is no units and dimensions. Therefore, it is a dimensionless physical quantity. Then B is correct. C. Relative humidity. We are defining relative density as a percentage. Relative density means relative humidity as a percentage. We are defining relative humidity as a percentage. Therefore, it has no dimensions and units. we can define relative humidity as vapor mass in a volume divided by saturated vapor mass for the same volume at the same temperature multiplied by 100%. Then it has no dimensions. Then C is correct. Dimensionless quantity. Therefore, B and C correct. Third one is the answer for question number 24. 25. Electron volt is unit of. We have found it. We know that it is energy. Then answer is 4 for the question number 25. Question number 26. A, B, C and D are physical quantities having different dimensions and K is a dimensionless constant. Consider the following relationships. For the above relationship, we have to select dimensionally valid physical quantities. Then we can consider A. In part A, K A to the power 3 equals B. Then dimensions of A cube should be equal to dimensions of B if it is correct. And B statement is given as D equals AC. D equals AC. C statement is A equals KB. We can't get C because of K is dimensionless constant and if therefore A should have same dimensions as B if this equation is correct, but they have given A, B, C, D are physical quantities having different dimensions, therefore C is incorrect. Then we can get A and B could be dimensionally valid. Therefore, answer should be 3 for the question number 26. Question number 27. Units of pressure is. We have to select unit of pressure. We can use dimensions of pressure. We know that dimensions of pressure means force divided by area. We can get dimensions ml minus 1 t to the power minus 2. Then we can substitute SI units. M is kilograms, mass, L is meters, m to the power minus 1, S is seconds to the power minus 2. Kilogram, m minus 1, S to the power minus 2. Then answer is third one for the question number 27. Then question number 28. X, Y and Z represent three physical quantities with different dimensions. They can be combined from other physical quantities, quantity P. The form P equals AX plus BY plus CZ. Which of the following expressions has different dimensions from the rest? There are three terms in the given equation. If it is dimensionally correct, all three terms should have same dimension. Then AX is the first term in right hand side. We can consider dimensions of AX is the dimension of a term of given expression, given equation. And second one, AX minus CZ. AX minus CZ is first term minus third term in the right hand side. We have to get the difference between first term and third term. We know that if a physical quantity, if we consider difference between two physical quantities, it has same physical quantities. Therefore, its dimension also same as the dimension of a term in the equation. Therefore, first one and second one has same dimensions. Third one, AX into CZ divided by BY. first term multiplied by third term divided by second term. We can cancel out good dimensions of a term in the equation ax into cz divided by by. We know that these three terms have same dimensions. Therefore, we can cancel out dimensions of one term. Then finally we can get dimensions of third answer also, dimensions of a term in the given equation. Therefore, it has same dimensions. Fourth one, by squared divided by p. By squared means square of a term in the equation. We have to divide by term. Therefore, we can cancel out dimensions of one term. Then dimensions of by could be obtained. It also same as the other answers. Fifth one, by into cz. Now there are two terms and there is the product between two terms. When considering product of two terms, it should have dimensions, square of dimensions of a term in the equation. It is different from other answers. Then answer fifth one is the correct answer for the question number 28. Then 29. Which of the following is not a fundamental quantity, fundamental unit? First one is meters. We know that it is fundamental. Joules is not a fundamental unit. Candela is fundamental. Kelvin fundamental. Mole fundamental. Then answer is 2 for the question number 29. 30. The dimensions of gravitational constant is given by. I will write the equation for Newton's gravitational law. If there are two masses, capital M and simple m, the interaction gravitational force is directly proportional to product of masses divided by distance between two square of distance between two masses. It is the universal gravitational law. Then we can use constant for the proportional equation to convert an equation. Constant value is g, it is universal gravitational constant. Then we can get gmm over r squared. We have to find dimensions of g. Then I will subject g fr squared divided by mm. Then we can write dimensions of g. F is force, ma t minus 2. R is a distance means it is a length to the power 2. Mass into mass, m into m. We can cancel out one m term, m minus 1, a to the power 3, t to the power minus 2. It is dimensions of gravitational constant, m minus 1, a to the power 3, t minus 2. Answer is 4 for the question number 30.